Hello and welcome back. Today we are going to be looking at constitutional isomers of alkanes. So, you know what constitutional isomers were. We covered those back in chapter 1. So let's just do a recap of what they are. They're different ways atoms can be arranged to form the same chemical structure. So, what in the world does that mean? Well, let's take this example. Methane, does it have any isomers? Quick answer, no, it literally does not. Next, ethane, does it have any? No, because there's no other way you can arrange the carbons. Propane, does it have any? Well, yes, it does. It's only one. Same with methane and ethane. But butane is when it starts to get really interesting. Butane has 2 isomers. Notice how it has 4 carbons. So you can arrange them like that, or you could take that carbon and put it over there, making it look like that. Pretty cool, right? And how we're going to do it from butane and on is we know that butane has 2 isomers, right? And what we're going to do from there is we're going to double the number, and then we're going to subtract 1. So if butane has 2, we double it, 4, subtract 1. So pentane has 3 isomers. Double it, 6, subtract 1, 5. Hexane has 5 isomers. Double it, subtract 1. Heptane has 9. And do it again. Octane has 17, which is suddenly a huge number. And so on. It gets pretty big. So some pretty big numbers, like 33 and 65, and really huge numbers all the way until like a quintillion or something for carbons that are only like 50 carbons long, which is pretty cool, but it's actually pretty understandable because there are infinite different ways you can arrange all the carbon atoms on Earth, literally. So, what's the trick about isomers? Well, there's not a trick with regular isomers, but with alkanes, it can be difficult. You know why? You could draw the same isomer twice without knowing it. Want me to show you? Let's go. So, we know that pentane has how many isomers? It has 3, right? So, let's start drawing them. We know the regular one is just always the chain. Right, that's the chain for pentane. We could take that one and put it over there for it to look like that. And what else could we do? Well, what else can we do to make this have an isomer? Well, we could also... Alright, so do you realize any mistakes that we've made? Look carefully, because I purposely made a mistake for us to look at. Well, it's that this one is pretty much identical to that one, right? It has that 2-prong coming out of a 2-carbon chain. 2 prongs coming out of a 2-carbon chain with an extra carbon in the center. So what is the other isomer of pentane? We can't draw identical isomers. Well, what is it? Well, it is when we take them to form something like this. Like that, kind of like an X. We draw it like an X because we don't want it to look like a plus, because pluses are used in chemical reactions. X's are generally not. And that's all you gotta know about constitutional isomers of alkanes.